Hello everyone. For today's video, we're going to discuss about internal estimates for the population mean when standard deviation is unknown. Suppose the standard deviation or the population standard deviation is not known, as is often the case. And then it must be estimated by using S, or the sample standard deviation, which is the standard deviation of the sample. When S is used and the sample size is small, we use a different kind of distribution called t-distribution. When t-distribution is used, remember the following. So first, the samples must be simple random samples and are taken from normal or approximately normal distributions. Second, instead of using the normal statistics formula, this formula, which requires the population standard deviation, we use the statistics T with this formula. So in which the sample standard deviation S replaces the standard deviation or the population standard deviation. So this test statistics is also called t-test. So now let's talk about how to find the value of t on the t-table. So let's say n is equals to 15 at 95% confidence level. So first thing is to find the degrees of freedom with the formula n minus 1. So since our n is equals to 15, 15 minus 1 is equals to 14. So we are going to look for the 14 on the t-table, under the degree of freedom. So here is 14. And look for the 95% confidence level. So here is the 95%, and we are going to look for the value in which the 14 degree of freedom and the 95% confidence level intersect. So, and the value for t is equals to 2.145. So if the n is equals to 15 at 95% level of confidence, our t value is equals to 2.145. So for number 2, let's say still our n is equals to 15 while our confidence level is 99%. So again, we're going to look for the degree of freedom. So 15 minus 1 is equals to 14. So here is 14. And then look for the 99%. So here is the 99%. And here they intersect. Okay? So for 99% level of confidence with the n size or the size 15, the t value is equals to 2.977. In determining the interval estimates for the population mean when the population standard deviation is unknown, follow the suggested steps. So first, describe the population parameter of interest. Second, check the specifics of the confidence criteria, so normality and the test statistics. Then, select the level of confidence interval and note the critical values. Then fourth, note the given values and find the point estimate. Then fifth, compute the error or the margin of error and find the interval estimate. And lastly, interpret the results. So these are the important formulas that we are going to deal when we are determining interval estimate. So we have the margin of error with this formula. So E is equals to the critical value of T multiplied to the sample standard deviation over the square root of the size. And of course, for the interval estimate formula, we have the sample mean less for the lower, this is for the lower interval, upper interval. So for the lower, we're going to subtract the margin of error from the sample mean, and while from the upper interval, we have to add it, or we have to add the margin of error to the sample mean. Okay, so let's have an example. So let's say we have the given problem. So these are the given. So we have the size of 20, the sample mean of 82.5, the sample standard deviation of 3. So this is the parent population is normally distributed. So use the 95% confidence level to find first the point estimate, second the error of margin, and lastly the interval estimate for the population mean. Okay, so the first step is the parameter of interest is the mean of the population where the sample comes from. Okay, and after that, step 2, the sample information that consists of size n is equals to 20 and the sample standard deviation is equals to 3 comes from a parent population that is normally distributed. So the test statistics is the t-test. So we're going to use t-test. Then we're going to find the confidence level. So at 95% confidence, the level of significance is equals to 0.05 with the degrees of freedom is equals to 19. So with a critical value of t, positive, negative 2.093, so you can find it from the t table. So by just looking for the degrees of freedom 19 and the 95% confidence level. Then next, we're going to determine other givens. So we have the n or the size is equals to 20, the sample mean is equals to 82.5, and the sample standard deviation is equals to 3. So the point estimate of the population mean is 82.5. So that is also the sample mean. So next, we're going to compute for the margin of error. So this is the formula in finding the margin of error. So we're just going to substitute all the givens to this formula. So since we already identified the t value, which is positive negative 2.093, we're just going to substitute it here. Then of course, we have the sample standard deviation, which is 3, and of course, the square root of the size 20. So we will arrive at the answer 2.093 multiplied to 0.67 is equals to the margin of error 1.40. So now we're going to find the interval estimate. So we have this formula in finding the interval estimate. So first, we're going to look for the lower interval estimate. So to find the lower interval estimate, we're just going to subtract the margin of error, which is 1.4, from the sample mean, which is 82.5. So 82.5 less 1.4 is equals to 81.10. So 81.10 is our lower interval estimate. Whereas for our upper interval estimate, we're going to add the margin of error 1.4 to the sample mean, which is 82.5. So 82.5 plus 1.4 is equals to 83.90. So 83.90 is our upper interval estimate. And for our results, so these are the interpretations. So the margin of error is equals to 1.4. So we can say with 95% confidence that the interval estimates between 81.10 and 83.9 contains the population mean, which is 82.5 on a sample size of 20. So that would be all for this video. So I hope you learned something. Goodbye!